Right. Thank you, Roberto, and thank you, Alireza, for again 2 very nice presentations. We have, in the meantime, quite large number of questions. As said before, some that were already asked during the first session. So I'll try to summarize some of them together. There's a number of questions that relate to the use of air filters or air cleaners as an alternative to ventilation. So one of the statements is based on the Wells-Riley equation, they are both removing particles, so they both work. But in real practice, what are guidelines or how can they be used as equivalents? Maybe Alireza, you can start, and then we can go to Cath for or Roberto for further thoughts on that.
So the question is about rotary heat recovery systems?
No, air cleaners. So
yeah, air cleaners. Sorry, I didn't hear exactly what you say about the air cleaner. Could you please repeat it?
Sure. So there are a number of questions that suggest that based on the theoretical equations, using ventilation or air cleaning has the same effect. So in theory, but what about in practice? What can we recommend using air cleaners? What are the conditions that need to be fulfilled where they can have the same effect as ventilation in terms of protection for COVID?
My short answer to this question is that first of all, we have to use ventilation, and air cleaning actually is as a complementary to ventilation system. So I will not recommend that using only air cleaner, but I mean there is a lot of air cleaner, and but we have, I don't know if you have time to go in detail and discuss about that now.
Okay, Roberto, did you do any experiments using air cleaners?
Yes, I can tell you something about that. For first, of course, an air cleaner is an add-on to the normal ventilation system. If this ventilation system is not has not enough capacity or whatever, maybe you can use air cleaners. But I think there's also major concerns about air cleaners, because first, often they are put inside of a room, and do they really clean the whole room? That's a big question. Then a second question is what type of technology is used. I personally have some experience with HEPA filters as a recirculation unit, and we did some tests in hospitals, and we can see it can reduce the amount of particles rather fast, much farther than the normal ventilation system that is in a room. So in that case, maybe it can help, but it's also a big question if to what amount, to what extent is the airborne route helping to get an infection? Because we don't know that yet. We all discuss about ventilation, and ventilation is very, very important. Yes, it is, but there is no proof whatsoever that there is a real contamination going on through the air. So that's not proven yet. We have the assumptions that it can be done like that, but real proof evidence is not there. But there's also no evidence that it is not going through the air. So it's still, I think, a part of research that should be filled in. So I think that it's in special situations, air cleaners can help. But if
okay, I think both Cath can answer on the part related to the proof of the airborne infection route, and that's also one of the questions that came up. And also, I think Andy would like to add something about the use of air cleaners. But Cath, can you maybe go
So,
first?
do we have proof of airborne infection? No, we don't. Do we have proof of any mechanism of infection? No, we don't, but we know infection's happening. I think this is one of the real challenges, is what's the burden you need to get that proof? And you know, how much we will always, we do with every disease, we always have to make a certain amount of assumption. And you know, it's very hard for any disease to get that absolute. I mean, for tuberculosis, it took a long time. Eventually, it was proven by the fact it were transferred from humans to guinea pigs through the air. But it was only maybe 10 years ago that we knew the variability in that, and the huge variation between people. So I think the evidence at the moment points to airborne transmission happening some of the time. Certainly long range airborne transmission happens some of the time. It's most likely happening within the same room. There's little pockets of evidence from New Zealand and Australia which suggest it could go between two rooms, and it's hard to explain the super spreading outbreaks without it. But that's not to say that we can dismiss any of the other routes. I think we also need to bear in mind that actually when you're close to somebody, part of that transmission is airborne too, because a lot of that is inhalation. I think it's just not airborne in the classic sense of the word that's used in the medical field. But from the public's perspective, it's particles in the air.
Great, thanks for that clarification. And then Andy, you also wanted to chime in on the air cleaners?
Sure. I mean, I can't speak to transmission routes or proof or anything, but I'll just point out that in some buildings, you know, older buildings in this country and other places where there is no mechanical ventilation system, where they're ventilated only by leakage, you know, a portable air cleaner in the space, you know, is an option, you know, to reduce aerosol exposure and presumably reduce the rates of transmission. So, and you know, we keep talking about mechanically ventilated buildings. We have to remember there's a lot of buildings ventilated only by leakage.
Thank you. That is indeed a very good addition. We have another cluster of questions that have to do not with air cleaning, but with another aspect of Roberto's experiment, which is mixing of air. So there's a number of questions that there's the one highlighted here on the screen about airflow patterns that occur. There were the results that indicate that swirl diffusers and slot diffusers didn't show significantly different results. So Roberto, can you speak to that? And then again, since there are a number of questions related to that, if other speakers want to chime in, please let me know, so then we can have another round of comments.
Yeah, in our experiment in this mock-up for a restaurant, we could not find any significant differences between the two ventilation types. We did not investigate exactly why it was that, but what we saw was that the linear diffusers really had a very strong flow around the ceiling and had a very long distance they reached, and the squirrel diffusers, they really mixed up the air within a minute. It was very, very fast. That's what we saw, but we could not explain exactly why there was no difference between the two type of systems, because we expected there was. That was also the reason why we did this experiment. But we did not see any, in this setup, we didn't see any difference, maybe because of the screens, maybe because of that the room was not empty. There were a lot of tables in it, there were heat sources in it. Maybe that could be the reason for it, but we did not really investigate that part.
Yeah, I think one important item where there was also a question about was the walkthrough routine, which may also have helped to mix the air. I seem to remember some research from more than 5 years ago now from the University of Texas, where they showed that as soon as you start walking around in a room, it actually quite fast mixes the whole space. So that seems like something that is also up Andy's alley. Do you want to come in and comment on that, Andy?
Please, Andy.
Oh, yeah, here, can you, I kind of I missed half of that. I had a little internet problem. I'm sorry.
Okay, so the one of the things that comes up with mixing in the space is to do with moving around in the space. The experiments that Roberto showed had a person walking around in the space at intervals, and I seem to remember some research from University of Texas where they showed that that alone will cause almost instant mixing of the space.
Okay,
So
yeah.
what is your experience with that?
Yeah, I mean, my experience is that spaces are generally pretty well mixed, whether it's people moving or people just sitting there and they have thermal plumes or the computers or whatever. In general, to the first order, things are pretty well mixed. You got to work to make them unwell mixed. So I think the first step is get the ventilation air to the space, and then after that, if then maybe you start to worry or deal with mixing and distribution issues. But get the air there first. The air tends to mix pretty well, but that's very different. It's got to be, if you're sitting next to somebody who's ill and coughing, the mixing and the overall ventilation rate, that's not the strategy. It's to you leave the building or have them leave the building.
With that, yeah, sure. Go ahead.
I wanted to say I'm thinking about that with regard to the coronavirus and so on. So sometimes mixing is good, and sometimes air direction is good. For the mixing, if you look at the old building that we have now with the old ventilation system with focus on energy saving, so we cannot increase ventilation, air change rate so much with the existing ventilation system. So maybe the best way is to have a mixing in order to reduce the in the whole room of the concentration. For the new building, we have opportunities to change make advanced air distribution. So maybe the new building is much better to use air direction in this case.
Okay, thank you for that addition.
I think I'm going to be naughty and ask a question because I'm not supposed to do this, but quite a lot of buildings at the moment have got far less people in them than they were designed for, an awful lot less. So the heat loads in a lot of rooms and movement is significantly lower. And I'm just wondering whether Andy or any of the others could comment on actually what that might do to the mixing we might be going to see in spaces at the moment. Because my feeling is actually we might get less mixing than we would normally expect in certain spaces.
I guess you would probably get less mixing because you have less bodies generating heat and less computers operating unless they're remoting in or something, and less lights. Hadn't really thought about that. What I do think about is when people say, increase ventilation rates, if you've decreased the number of people, by a factor of 4, you've all of a sudden increased the ventilation per person by a factor of 4. I think that's a more important first order effect. Is it also influencing mixing? I think that's an interesting question. Which I haven't thought about, and I that won't keep me up at night. Buildings with really low ventilation rates, that would worry me a lot more. But that's a real interesting question. And that I just when we talk about big open plan offices with lots of people in cubicles and partitions, and now you reduce the occupancy to 25%, and what that does to the mixing, that's really a real interesting question.
Okay, we're already slightly over time, so although there are lots and lots of very interesting questions left, I don't think we can address them all, so I'll draw it to a close here. However, there were a number of questions that related to practical advice and questions for practical advice, what to do in certain types of buildings. I would like to refer those questions to the excellent advice that has been given by some of the organizations that Andy pointed out in the beginning of his slides, and that are also listed mostly on the Indoor Environmental Quality Global Alliance website that tries to kind of provide a lemma for all of these guidelines. Okay, so with that, I'll close the Q&A session, and it's back to Arnold for the end of the webinar.